Yeah, hi, I'm James Pitcher. I'm leading the marketing science team in the UK here at GfK. So yeah, great presentation, Andre. Hopefully you're going to stick around to help me answer questions on my presentation. So Andre did quite a more theoretical one. I'm going to show more of a practical example of how we can use Bayesian network in brand tracking work. Yeah, so I'm going to be talking about running key drivers analysis in brand trackers and looking at a comparison that we did where we compared the results of drivers analysis using Bayesian networks and Shapley value regression. So just to summarize what we're going to cover today, we'll start with doing a quick introduction to key drivers analysis and how we use it in brand tracking. And then we'll move on to the results comparison. So comparing the results that we get from our Bayesian networks models to the Shapley value regression, understanding what are the differences, and also importantly, why are there differences? And then we'll move on to looking at the stability of the results, both over time and across brands. And then we'll try and sum it up with some conclusions at the end. Okay, so just starting with an introduction to how we use key drivers analysis in brand trackers. So typically within brand trackers, we're asking in a survey setting, respondents how they think brands are performing on certain brand imagery perceptions. And then we can use key drivers analysis to understand how important each of those individual brand imagery perceptions are in driving some kind of overall brand performance measure. So typically we will look at what drives brand consideration, brand preference, brand recommendation, things like that. Now, a typical way of doing this drivers analysis is using regression. I'm sure a lot of you know this already, but in regression, we're creating an equation to explain the relationship between our brand imagery statements and our overall measure of brand performance. And this allows us to derive an importance score from the coefficients that we get from our model. And typically we're scaling these importance scores to sum up to 100% across all the perceptions inputs in our model. And we're often in market research and in a survey world using Shapley value regression because it accounts for the high level of correlation between our brand imagery statements. There are other methods that you can use, such as Johnson's regression or ridge regression, but Shapley value regression is a widely used technique to account for this high multi-collinearity. So in order for the rest of this presentation to make sense, I just need to quickly explain how at GfK we are measuring overall brand performance, because I'm going to be referring to these metrics throughout the presentation, and it might not make sense if I don't first explain what they are. So in GfK, in our brand tracking work, we're now using a very simple brand price conjoint exercise where we ask respondents in a survey setting to evaluate different brands on screen, which are showing at their relative prices. And we ask them, which brand would you buy? And then we iterate the respondent through multiple screens. And each screen, we're showing a different set of brands. We're varying the price as well. And in each screen, we're asking them which brand they would buy. And so from this exercise, we can derive our measures of overall brand performance. And so we have two measures that we're going to be looking at today. So we've got our brand choice measure, which is basically the conjoint share of preference. And in other words, this measures how many consumers are likely to buy the brand. And then we also have a brand premium measure, which is based on the price elasticity. So this measures how sensitive consumers are to price changes. Now, it's not really that important to know exactly how these metrics are calculated, but I just wanted to give you an idea of what these are, because we're going to be referring to them throughout the presentation. So now we've calculated our overall measures of brand performance, our brand choice and brand premium. We can then use key drivers analysis to understand the importance of brand imagery perceptions in driving these outcome measures. And traditionally, we do this using Shapley value regression, but what we've decided to do and was look into was, okay, can we use Bayesian network instead to run that key drivers analysis? So this led us to do a study where we compared the results of the two approaches. So just some details of the study. So it was quite a large study. We did it in two tech and durables categories, TVs and vacuum cleaners, in 3 countries, UK, France, and Italy, across 5 monthly waves. And in each wave, or in each cell, and in each wave, we had 200 respondents. So across all the waves and cells, we had quite a large sample. And so the inputs to our model were as follows. So we had 13 brand imagery perceptions that we were putting into our model. Each of these was asked on a yes-no association. So that respondents said which brands they associated with each of these imagery. So we've just got basically a binary scale for each of these statements. And then we've got our outcome measures, brand choice and brand premium, which are on a continuous scale. And then we're using key drivers analysis. So we're comparing two methods, the Shapley value regression and the Bayesian networks. So some important things to note on our approach to using the Bayesian networks. We used one network structure for our brand choice model, and then we built a separate model using a separate network structure for our brand premium model. And then we used the same network structures for across all the categories, countries, and ways where we built models. So basically, for every model we built, we use the same structure for brand choice and the same structure for brand premium. Okay, so now let's look at the results and how the results of Bayesian networks compares with the Shapley value regression. Okay, so here we have the importance scores for the brand imagery perceptions. So what's important in driving brand choice to start with? And what we have here is that we have the importance scores that we get from the Bayesian networks in green, and we get the results from Shapley value regression in gray. So these importance scores, as I said, are scaled to sum up to 100% across all perceptions. And one of the kind of main difference that we see is that the importance score that we get for the top driver, so in this case, brand attachment, the importance score is much higher for Shapley value regression compared to the Bayesian networks. And then if we look at the results for brand premium, we again see that for the top driver, in this case, differentiation, this is much higher again for the Shapley value regression model compared to the Bayesian networks. And we do see some other differences as well. For example, the importance score we get in this model for brand attachment, and there is quite a large difference between the two methods. So to be able to quantify these differences a bit more, what we can do is calculate a rank correlation. So we do this by taking the rank of the importance scores that we get from both the Bayesian networks and Shapley value regression models, and then we can run a simple experience rank correlation to see how well those ranks align. And so in this example, we have a high correlation of 0.86, meaning the ranks align pretty well. So here we have the rank correlations for all the cells in our study. So along the bottom here, we've got results for the total, so across all cells. Then we've got Italy TV, Italy vacuum cleaners, France TV, France vacuum cleaners, GB TV, GB vacuum cleaners. And what we can see is that, well, in blue, we have the rank correlation for brand choice, and these correlations are all pretty high. So they're all above 0.7, meaning the results are consistent across the two methods. But when we look at the brand premium in red, overall, we have a correlation of only 0.53. In some cells, we do have a very strong correlation, like France TV, but then we have some cells, such as Italy vacuum cleaners here, we've only got a correlation of 0.4. And this means that the rank of the importance scores is quite different from the two methods, which ultimately means the insights and recommendations that you're going to give to the client is potentially going to be quite different depending on the method that you use. So on the previous slide, we were just comparing the drivers models run at the total category level, but we can also run drivers models for individual brands. So taking any individual brand and seeing what's important in driving that brand's brand choice and brand premium. And this is what we've done here. So on the left here, we've got the plots for brand choice. And this is every model that we've run both at the category level and brand level. And what you can see in this circle here is that there's only a few brands which have a low correlation between the two methods or a negative one. So the majority of the cases, we're getting a good correlation and the results are pretty consistent across the two methods. But when we look at brand premium, we get a lot of brands where there's a very low correlation between the two methods. And in a lot of cases, we actually have quite strong negative correlations. Again, meaning ultimately the insights that you deliver to the client could be somewhat different. Okay, so another thing we can compare is the range of importance scores across the two methods give. So for Bayesian networks in green, we have importance scores that range from 12.8 all the way down to 4.2. So that gives us a range of 8.6. And then for Shapley value regression, that ranges from 23.5 all the way down to 2.7. So we have a much wider range of the importance scores, in this case, 20.8. So here we've calculated this for every cell. And what you can see is for both brand choice and premium, the ranges in the importance scores are higher for Shapley value regression, especially for the drivers of brand choice. These ranges are notably higher. And part of the reason for this was what I said earlier, that because you've got that top driver is much higher for the Shapley value regression with the Bayesian network. Now, the reason why we see results between the two methods is that it's largely down to the fact that Bayesian network is able to measure both not only the direct impact on the outcome measure, but also to take into account the indirect impacts that the variables are having through the other independent variables that are present in the model. And I will now demonstrate why this is the case using an example. And here we have an example based on simulated data where we've got 7 independent variables and 1 dependent variable. So the correlation matrix on this simulated data looks like this. And when we look at how these 7 independent variables correlate with our dependent measure, we see IV3 is the most correlated, followed by IV1. And then the rest of the IVs don't really have much of a correlation at all. So when we run the Shapley value regression, it's unsurprising that the IV3, which had the highest correlation, has the highest importance score, but it really dominates with over 70% importance. And then followed by IV1, which had the next strongest correlation. And then the rest of the variables which didn't have much of a correlation, don't get that much importance at all. But what this ignores is that the correlation of the variables have with each other. And that's what gets taken into account more explicitly in the Bayesian network. So although some of these variables aren't having a strong direct correlation with a dependent variable, they're correlating with each other. And this gets reflected in the relationships that we build in our Bayesian network. And therefore, although many of the IVs might not drive the dependent variable directly, they can drive it by indirect means, by driving another independent variable, which then goes on to drive the dependent variable. And when we look at the importance scores that we get, V3 is still the most important variable, followed by V1, but the importance is much reduced, and the importance is much more spread out across all the variables. So that was a theoretical example using simulated data. Let's now look at a real example using some real data. So this was a slightly different study based on washing machines, laptops, TVs, and mobile phones in Germany and the UK. And what we can see here is that this statement has values I strongly identify with. It has much more importance in our Bayesian networks model, than a Shapley value. So much higher in the Bayesian networks. So let's have a look at why this is the case. It's basically because the Bayesian networks is able to take into account the indirect effect. So here we have the drivers of brand attachment. And now brand attachment was one of the strongest drivers in driving a brand premium measure, the dependent variable in this case. And what we see is that this value statement has values I strongly identify with. This has the highest importance score in driving brand attachment. So in our Bayesian networks, this value statement is not only driving brand premium directly, but it's got a strong relationship with brand attachment, which then is the top driver for brand premium. So we get this indirect pathway as well. And so that value statement gets a higher importance than when you just take into account the direct effect only, like you do in a Shapley value regression model. Okay, so now let's look at the stability of the results, starting with the stability over time. Now, what we see on the left here is that we have the stability of the Bayesian network's importance scores over time. So for 5 monthly waves from February to June, we have the importance scores for each of the perceptions given by a Bayesian networks model. And we're looking at here the drivers of brand choice amongst Italy vacuum cleaners. And we can clearly see that the model is very stable across the months. And given that we're only looking over a 5-month period, we wouldn't expect that the importance of these perceptions to be dramatically changing in such a short time period. Now, when we look at the Same results this time for Shapley value regression. We do see some bigger changes in the importance scores. Now, then we look at drivers of brand premium, and this time we're going to look at France TV. Again, it's a similar story. We see the results for Bayesian networks are very stable over time. But when we look at the Shapley value regression, we start to see some quite large differences from one wave to another. So we can quantify how stable the results are over time. But to do this, we've created a stability index. And the way we've done this is that we calculate the importance score of each of the perceptions in each of the waves. And then we look at the range of these importance scores across those 5 monthly waves. And then we're going to take the median value of these ranges of the importance score across all perceptions. And this gives us a stability index. And the lower this score, the more stable the results. And conversely, the higher, the less stable. So here we have the stability index calculated for all our cells, for both brand choice and brand premium. And you can clearly see in green that the Bayesian network stability index is much lower than the Shapley value, meaning that the Bayesian networks is much more stable than the Shapley value regression. I should note that we have only got 200 respondents in each monthly wave. And really, when you're doing the projects, you wouldn't be running a driver's analysis every month on a 200 sample. Really, you aggregate the waves across maybe 6 months or a year, so you get a larger sample size, and that helps to account with the stability. But really, we're showing this multi-month really just to illustrate that the Bayesian networks approach is much more stable than the Shapley value regression. Okay, so next let's look at the stability across brands. So starting with the Bayesian networks, we've got the same output here, but instead of looking across 5 monthly waves, we're looking at drivers models for individual brands. Okay, so for Bayesian networks, we see that we do see some differences across brands, and this is what we'd expect. We don't expect the drivers for every brand to be exactly the same. Now, when we look at the drivers for Shapley value regression, we start to see some much larger differences, some quite wild differences in the importance scores we get across brands. And then looking at the drivers of premium, again, for Bayesian networks, it's fairly stable across brands, and we get much larger differences again for Shapley value regression. Now, we cannot say what the ideal level of stability is because we expect to see some differences across the brands. But when you start seeing such large differences across brands, that starts to become quite difficult to explain to a client in a presentation why those importance scores are so wildly different. And then if we calculate a stability index for Bayesian networks and Shapley value regression across brands, again, what we see is that the Bayesian networks approach is much more stable than the Shapley value regression. Now, the reason why Bayesian networks is more stable than the Shapley value regression is because we're using a consistent network structure across all the models that we're running. And this helps us inform a better model. Because if we think about Shapley value regression, the models are providing unstable results because there are some limitations in the data. It's just a survey. And when you're collecting brand imagery data in a survey, you're going to get a high level of correlation between the variables that you get. And Shapley value is designed to help deal with that, but it's not perfect in knowing how much importance to give to each perception when things are very highly correlated. And also you can get a lot of noise in the data, especially when you're looking at low base sizes. So it doesn't really take that much for much change from one wave to another, for example, to have quite a large impact in the importance scores that we can get. So the good thing about Bayesian networks is rather than relying on the data alone, we can inform the model using our prior expert knowledge. So we can define the relationships that we believe exist in the brand between the brand imagery perceptions using our expert knowledge and not relying on the data alone, which, because everything's so highly correlated, it might struggle to identify some of these relationships. And then by keeping these relationships consistent in each of the model that we build, that really helps make our results consistent, be it we're looking over different time periods or different brands. Because if you believe that relationship between those perceptions really exists, Well, you wouldn't expect that relationship to change from a month to month basis. You wouldn't expect it to change that quickly, nor would you really expect it to change across brands. You'd expect that to be that consistent. So we can create a network structure based on the data, but also an expert knowledge, lock that in, apply it to all the models that we run. And that really helps to keep the models consistent. Now, of course, over a longer time period, there'll probably come a point where you might think that the relationships might change, and you can always modify and update your network structure, go in a year's time or whenever you think is appropriate. Okay, so to sum up then, so there's some really clear benefits to using Bayesian networks when running key drivers analysis and brand trackers over more traditional approaches such as Shapley Bayesian regression. So as we've seen, it's more accurate in assessing the true impact of each input, as we're not only measuring the direct impact that perceptions are having on our outcome measure, but we're also measuring the indirect impacts. As we've seen, it's more stable over time, and across brands, which avoids any awkward conversations with clients when you're trying to explain massive differences. And also it's more actionable as clients can see the key pathways to success. So you're not just delivering a set of important scores that sums up to 100%. You can also provide the network structure, which allows the client to visualize the different pathways to ultimately improving their brand performance, because you can map out the different stages as you move through the network, what's ultimately going to get to driving your overall brand performance. And there may be different ways that you can move across that network structure. And at that point, it starts becoming much more of a consultative tool. And you can start having much more in-depth conversations with clients about their business and their strategy. So yeah, we'd encourage everyone, the next time you run key drivers analysis, to give Bayesian networks a go and have some fun with it. So that sums up all we wanted to cover today. So thanks everyone for listening. Hope you found it useful.